So got a cannon on it. And
I'm grateful for a new office. So if you guys come and find me now, it's like 3 less steps. So we're leaving.
yeah,
So anybody has to bring me stuff. Not where I was.
got the corner office now.
3 steps closer.
Cameron, can you hear that?
Yep. It's back.
Anybody else? All right.
Hey, Ben. I'm grateful for Ryan and Joe for helping me with get the casting wheels on our cardboard tables.
Heck yeah, certainly. I got one. I'm proud. So I'm going through some stuff with Bentley's mom, and I'm really proud of myself for the growth that I've shown in handling the situation, because 5 years ago I would have had a whole different experience. Yeah. So just when I come into this experiences where there's like confrontation with her, I feel like I've been handling myself much better.
Yeah.
It's just a big step for me in my life.
Yes.
Woo!
Before we get started, I got to shout out Morgan. She made this cool little graphic for the Fat American for the 8 wastes. Nice. What is one-piece flow? One-piece flow is sometimes referred to as continuous flow, or single-piece flow is a discrete production method used in lean manufacturing that closely associated with the just-in-time system, which is a key concept within the Toyota production system. One-piece flow is also the most important factor when it comes to developing a lean environment. One-piece flow is closely associated with the just-in-time system because manufactured goods go through a continuous flow of steps with no downtime. In a one-piece flow setup, workstations are arranged in a way where production can flow continuously, one step at a time through the process from setup until completion. Goes into the next zone. They're just a little visual representations. In a cellular format. Obviously, we're limited at this building, but at the new building, Brian has been tweaking it to make it what makes sense for the most possible the stuff to flow through with ease. But cellular flow is the most efficient strategy for higher efficiency. It's used in a one-piece flow combination with cellular layout, where all necessary equipment is located in a single area during the cycle of operations. This is simply layout or setting up all necessary materials or machineries according to the order of the workflow. Kind of what we've been used to is batch production.
Can you broadcast your voices?
Yeah, so
Yell at us.
There's a lot of sources and experiments where one-piece flow is compared with the batch production process. Unlike in one-piece flow where each item go one at a time through each step, batch production is a method wherein goods or items are produced by batch, in bulk, or in mass. The good in batch production have to be finished before it can be moved to another step. And then I have a video. Hopefully she works.
One is one-piece flow versus 5 and 10 batch sizes, and I think you might be quite surprised. I know I was. Before we push go on this simulation, there's a few things that we want to share with you. And the first one is that there's a section for each batch size. So there's a batch of 1 and a batch of 5 and a batch of 10.
Now, regardless of the batch size, the processing time will remain exactly the same. The only difference is if you have a batch of 5, you can't move from complete to the next staging area until all 5 are done. And the same for a batch of 10. You need a full batch of 10 before you can move to the next staging area. So what did we think of that demo? Is that not crazy or what? To just start having you question, like, how big are our batches right now? And would there be any benefit to reducing them? We will give you a quick warning. Don't run out in the factory and say we have to build everything one at a time. That will be very, very bad. This is just an introduction to single piece flow, and we'll teach you all about it in coming lessons.
This one is one piece flow versus 5 and 10 batch size. This one is
For an example, when materials move through the manufacturing process in batches, it can be inefficient and additional steps with added production time and therefore increased lead times. In a one-piece flow, a product is completed first before beginning with the next item. There's just a little visual representation there. Some advantages for it are obviously shorter production times, which lead to happier customers, happier employees, and less inventory. And it's quicker to detect errors or anything if you work on one thing at a time compared to many. Then better quality product if you're just focusing on one thing opposed to a batch of bunch of bumpers per se. And reduce waste, which go with the better product, and then a safer environment also, and then improve workers' morale. And obviously, the one-piece flow won't always work in every department. For engineering, for example, it'll only work for a certain amount of time until, say, you design the thing and it goes to get cut. You might be on the wrong material, or you're waiting for the press, or say it's ready to be tested after it moves through the process, and say the vehicle's gone or missing or not available for whatever reason. Does anybody have any examples of one-piece flow might not working in any other department?
Maybe my department might not be such a real good idea, given setup time in my machines right at the moment. So
Right.
to set the machine up for an hour to dial it in, make one piece doesn't make a whole lot of sense.
Yeah.
Yeah, but you are running one piece of the machine, right? So you're not batching 5, 6, 7 machines. You're going one in, one out, one in, one out, one in, one out, right?
Well,
So
yeah.
the only step that would go further than that would be you had to physically move the inventory to the next department if they already needed it. So in a way, you are one piece flowing your batch, right? So it's not like you're batching 20 of them at a time inside a machine.
I can just elaborate on the engineering one too. So we had 5 rows, one for each of us upstairs. And the idea was each one of us would have one product. And Colin was pretty close. He was like halfway or close to finishing something when we implemented this board. So he got to, there's 10 steps or so. He got to like step 8 or 9 and realized that's when Cameron has to get involved and get it launched on the website, or we have to go get photos, and Morgan had to go get photos, and then Cameron had to work on the webpage. And he could have been all of his production stuff was ready, the event programs were ready, it was ready to launch. There's a couple day delay of when it could launch, because it's not all Colin's responsibility to get that product online. So in those couple of days, he was able to make headway on something else, and there was no way to record it on the board because he still had 2 cells left on the commission by work for his first product. So we switched to 2-piece flow, and then tried that for a little while. I mean, it's working better for sure. Because you get that first project to step 8 or 9, and there's a little bit of downtime at the end. You're able to get maybe the first 3 steps or 4 steps or 5 steps done on the next thing. So there's kind of like a small overlap, but we're still essentially one piece flowing 2 projects, if that makes any sense.
The robots might be one of the better examples of where one piece flow doesn't really make sense. So similar to Monty, like all the fixture setup time, load, unload, and then for majority of parts that run through that machine, we're running 4 at a time or 10 at a time, 15 at a time. I think it's also interesting though, because bumpers, we run close to one at a time. So it kind of does both, but it doesn't make sense to one piece for them. Yeah.
Powder coat's a good example for that, 'cause when you're running parts through the oven, with one piece flow, you can skid plate in like 2 minutes,
Yeah.
and it takes about 21 minutes for it to bake, so. You're not just gonna throw one skid plate in the oven at a time.
Waste of time. Anybody else? No. All right, in conclusion, one piece flow will ultimately create less mistakes and errors while maintaining a higher quality product with shorter production time. Will also increase our lead times. This results in happier customers and even happier employees without so much of a workload. Any questions?
In regards to departments that don't work for one piece flow, and they'll, like, not necessarily one piece, but smaller batches.
Yeah.
So powder coat is an example. Once the flow of product changes, they're going to have to go to probably running their small carts more continuously, as opposed to waiting and loading 4 carts and then running 4 carts through the process and like that. They're gonna have to maintain continuous flow through their process, which right now they don't have flow. So hopefully that gives them flow. And then for Leon the robot, the only reason that he's running multiples of a certain part is because that was the way we set the fixture.
Yeah.
So now, as he builds new fixtures, he's more mindful of the true pull of the product. So he's changing the fixtures to match more in line with the pull, right?
Yeah.
The same thing will probably happen with Monty, where his current batch sizes may be larger, but as we look at the real pull of that part, we're gonna reduce the size down so that we're not overproducing just to stick stuff on the shelf. And so then each department kind of has more of a flow instead of like this, like rush of parts, nothing to do, then rush of parts, and nothing to do.
Right. It's almost gonna be up to us to figure out what one piece in your area looks like. I mean, for a welder, it's a bumper, right? Or something that takes a considerable amount of time. But for powder coat, their one piece isn't, like, obviously they're not gonna park up one piece at a time, but their one piece is one cart, right, moving forward. So if they get that cart done and move that cart to shipping before they start another cart, opposed to starting, powder coating 3 carts just because they're in the thick of it, that's kind of how you will take it along quicker, even though you're not technically doing one piece. It's identifying what your one piece is, whether it be 5 things or 1 thing or 10 things.
And one piece flow may change as equipment changes too. Like if you look at our powder coating process, we have 1 oven. So that's like, what can we stick in it, right? If you go to like Weber's, where we used to get our powder coat done, their system is basically a track that is like a conveyor that rolls through the ovens. They are doing 1 piece at a time. Hang it, let it go, hang it, let it go, hang it, let it go. It's like their system is different. So we have 1 big oven. So right now for powder coat, our 1 piece flow looks like what Alex was saying is a cart. And that may change as like we get new robots or we get new little carts that run around or we get, all these little different things. Our 1 piece flow may change.
The idea of creating flow is more important than necessarily 1 piece.
Yes.
Right, it's a continuous flow to try to take the waves out so that, fabrication, you guys don't see a swell of jobs and no jobs, and swell of jobs and no jobs. You see continuous movement. Same with shipping, powder coating is running 5, 6 carts. These guys can dry up over here, and the next thing you know, they're buried in carts. So, and then now powder coat's looking for stuff to do. So it's all about trying to figure out how to make our flow work. The best description I found of what we do is batch to queue. So we batch a job and then it sits in a queue. Then we batch it in a queue, and batches it in queues. So I want to try to get away from that batch to queue and more of like, if we do a batch, that it's actually going and processing through the flow so that the product's just not sitting. There's no point aging our inventory. We're not making wine.
It's like the carriers. The carriers went from a job of 14 to 7, I think. And it wouldn't make sense just to throw 1 up on the robot, but you're more than likely to get 7 done in a day, get all those pushed through.
Going to tie it like that carrier job back into the kind of infographic that he had, I think we could all see like the top, middle and bottom, that middle group that was kind of that mid size where you still reduce your batch size, still flow through the process a whole lot quicker.
think a good example, that we had recently, just this week, really, with all these crossbars, right? We had a bunch of crossbars come in, we've had an influx and roof rack mortars. Now Powder Coast been slammed with crossbars, right? All of a sudden, they've got 600-800 crossbars that line process. Now they've got to work that log jam through the system. And if we have that one piece flow, then we're gonna be ordering the crossbars and processing the crossbars in a better consistent flow where we don't have that bottleneck.
That was a big order that came in. I hadn't seen an order that size in a long time. So we're gonna give you another 60 minutes here.
On your improvement videos, you can one piece flow your improvement video, so you can shoot a clip, pull it into CapCut, shoot your next clip, pull it into CapCut. That way you're not batching that video at the end, kind of building it as you go. And it kind of helps build your timeline as well. So I think you can apply one piece flow to more things than just work. The other things and other activities that you're doing to try to streamline that process through.
And the crossbars, are we trying to push 800 through because we need it this week or first?
Yes.
Oh, okay. Well, the end of the month, that's what we always do, right? Put a big burden on the end of the month every month. Never changes.
Good for everyone.
And then we got Colin tomorrow, Travis on Monday, Taylor's on Tuesday, John Wednesday, and then Cole's doing next Thursday.
Thank you.
Thanks for bearing.
Yeah.